Good morning, one and all. Good morning, one and all. My name is Arampal Akil from Institution of Aeronautical Engineering, and my role number as follows on the screen: 20951J2105. I am related to the Aeronautical Engineering branch and probability statistics. Today, my topic is multivariate normal distribution, which is related to tech talk. The multivariate normal distribution. We should be consider the multivariate normal distribution. It would seem that applied problems are so complex that it would be only the interesting from the multivariate perspectives. It is a mathematical traceable for a large number of problems, and therefore the progressive towards answers to statistical questions can be provided even if only approximately so. Because it is a traceable for so many problems, it provides insight in techniques based upon the other distributions or even non-parameter techniques. For this, it is often a benchmark against which other the methods are judged. For some problems, it serves as a reasonable models for the data. In other instances, transformations can be applied to the set of response to have a set conform to multivariate multivariate motions normality. The simple distribution of the many multivariate statistics are the normal regardless of the variant distribution. Multivariate central limit theorems. Thus, for a large simple size, we may be able to make use of a result for the multivariate normal distribution to answer our statistical questions. Even in the parent distribution is not multivariate. Consider Consider first univariate normal distribution with the parameters mu, the mean, and sigma, the variance for the random variable x. F of x is equals to root to 1 by 2 pi sigma square e power minus 1 by 2 x minus mu whole square by sigma square for minus infinity less than x less than infinity, comma, minus infinity less than mu less than infinity, and sigma square greater than 0. Now rewrite the exponent x minus mu whole square by sigma square using the linear algebraic formulations x minus mu power j sigma square whole power minus 1 x minus mu. The formulation matches that for generalization or mall for the square distance x minus mu whole power j summation whole inverse x minus mu, where x and the mu are the vectors. The multivariate normal distribution can be derived by the substituting the formula square distance formula into the univariate formula and normalizing the distribution such that total probability of the distribution is 1. This yields f of x is equals to 1 by 2 pi 3 by 2 summation summation whole power 1 by 2 e power minus 1 by 2 x minus mu summation whole inverse x minus mu. For minus infinity less than infinity, minus infinity less than mu less than infinity, and summation positive definite. In the bivariate normal case, the square distance formula in the terms of the indivisible mean mu1 and the mu2 variance sigma 1 and sigma 2 corrections rho of 1 2 x minus mu whole power j summation whole inverse x minus mu 1 by 1 minus rho square 1 to x1 as equation follows on the screen. Equation 3. Properties of the multivariate normal distribution. Let x minus np mu comma summation be the p-variate multivariate normal with the mean mu and the variance covariance matrix x where x equals to and mu equals to summation equals to the solid ellipse of all x such that x minus mu summation inverse x minus mu less than or equal to x continuous 1 minus alpha 100% of the probability of the distribution. This is also the implies the continuous delivered region of the constant probability about the mu are given by the x minus mu whole power j summation x minus mu equal to x into alpha. The semi-axis of the elliptical minus 1 minus alpha is 100% probability are the given by the eigenvalues lambda 1 and the eigenvectors such that semi-axis are plus or minus c into lambda I into g I where c square equal to x square p into alpha. All subsets of x are themselves multivariate normal. Any linear combinations of x I x cj x equals c1 x1 plus c2 x2 cp xp. The normal distribution cj x minus n into plus follows on the screen. Further Q linear combinations c power j x cube here is the multinormal. Let cj then subdivided the vectors x into subsets x1 and x2 and so that x equals to x1 x2. The condition distribution x1 and x2 equals to x2 comma f of x capital x1 by x2 equals to x2. Parameter of a multivariate of p into mu 2 plus summation of 1 to summation inverse 2 to x2 minus mu 2 summation of 1 1 summation of 1 1 minus summation of 1 to summation inverse 2 to summation of 2 1. And if two variants x1 and x2 are multivariate normal or uncorrected row of 1 to 0 equals to m plus sigma 1 to equals to 0, then x1 and x2 the independent. This property is not in general true for the other distribution. However, it is also true that if two varieties are independent, then they are uncorrectable no matter which the joint distribution is sample distribution of the multivariate normal. Let x equals to be the vector of the sample means of the sample of the size n from the multivariate normal distribution of x. Then let S be the sample variance covariance matrices computed from the sample size of n from the multivariate normal distribution of x n minus 1 into s and w of n minus 1 into summation a Western distribution with n minus 1 degree of freedom. The density function of W for S and density does not exist where n less than or equal to. Further, S must be positive definitely. X and S are stochastic independent at n minus 1 into S sum of W n minus 1 into summation then n minus 1 c of S minus 2. Let A1 equals to n1 minus 1 into S1 summation of W n1 minus 1 summation A2 equals to n2 minus 1 into S2 W minus n2 minus 1 into summation where S1 S2 are independent estimates of summation A1 plus A2 of is a polite estimated at x1 x2 and so x1 be the sample random variables x1 x2 the approximately central limit of a theorem. It says that the variant n minus 1 we can delete x1 and multiply for the n minus 1 p approximately confidentially region for the mu of a given. As is to multivariant, so as is to multivariant, as is to multivariant normal. This method for assuming multivariate normal of a set data makes us the properties of the multivariate normal distribution discussed in the early. You should also note that to assume the common multivariate normal distribution for each of the data. The same means mu and the covariance matrices summation. This means that for many sets of data sets on the multivariate normality, we need to be the preferred or residuals rather than the raw materials. Some ideas considered all marginal distributions must be normal. Check the normality. Each of the variant area does not confirm the normal distribution. Then set the variant cannot be multivariate steps for the QQ normal distribution, but order of the observation for the smallest to the largest. Those are the order of the statistics of the random variables and the estimated quantities of the distribution from which they are will sample the quantity of value at which the certain permutation distribution is lesser than or equals to the value estimated proportions of the distribution that should be less than the equal to the value of each order on said I minus 1 by 2 by n, where I is the rank of the observation. Compute the expected quantities of the normal distribution Q equal to pi inverse I minus 1 by 2 by n, where pi inverse is the inverse of the standard normal cumulative distribution function. Plot the observation of quantities x1 various of the expected quantities Q. I check the for linearity of the property to observe the quantities corresponding with the normal distribution, then the points will plot on the straight line. If not rejected, the normality will not towards minimum sample of 20 to have confidence. All the pairs of the variable must be the biovariant normal producing the scatter spreads. One variable intensity of the regions and corresponding are of elliptical and the linear relationship among the linear combinations of the variables are the normal. Check the linear combination for the normality. For the check the principal components corresponding the eigenvectors for the normality. Check the pairs of the linear combination and the principal components of the bivariant normal. Reject the normal atom bivariant scalar distance over the propagation, meaning the vectors of the distributed and degree of the freedom estimated and the propagation. Mean vector of the sample means vector and the estimated population of the covariance of the sample covariance. Compute the scalar distance observation of the sample vector. Check the steps for the QQ estimation. Compute d square equals to x minus x t square. This follows on the equation of the di square from the sample of the large to get the quantities of the distribution. Compute the expected quantities corresponding to d1 square equals I1 to let the d1 square versus to check the normality of the plot of the distribution. So reaches the multivariate distribution. Those steps can be repeated for the subsets and the linear distribution. This is the useful identification of problems multivariate normal C2. And check the order errors of the data if the identification the details and different from all others. Considering the transformation of one or more than variables, a variable may be, for example, follows log normal distribution, so logarithm transformations would be in order. Note the transformation considered. So alternative multivariant methods is available. Some techniques are given to BB 1986 density estimated data analysis and interference results. And for example, CMF random motion movement and carries method in biology second. Thank you. Thank you for giving this opportunity.